This lecture is going to define the term statistical significance, which you've probably seen in the media or in other courses. So what does statistical significance actually mean? And how does it relate to the material that we've covered already on probability and hypothesis testing? In this lecture, we'll cover three key ideas: the significance level, the p-value, and the statistical significance. So let's go through that example that we covered before on a clinical flu vaccine trial. So remember, there was a pharmaceutical company that was running a vaccine trial with 50 people in the treatment group that received the vaccine and 50 people in the control group that don't receive the vaccine. So we saw that 20% of people in the treatment group got the flu last year, 22% of people in the control group did not, or got the flu. And the question is the vaccine effective? We see that more people got the flu who didn't receive the vaccine. So we can really conclude that the reason why people in that treatment group who got the flu vaccine, why they fared better is because of this vaccine? Maybe it was just due to some sort of fluke. Maybe that we happen to sample people who have a better immune system and put them in the treatment group. So can we conclude that there is a likelihood that this difference is really there in the data and not as just due to chance? So let's go through these three pieces to come up with statistical significance to answer that question. So first is the p-value. The p-value is the probability that we would see the relationship that we find in that data due just to chance. So thinking about the flu vaccine example, there was a 2% difference in the treatment versus control groups. So can we conclude that that 2% difference is something that's real and not just due to randomly sampling people who are a little bit healthier and putting them in the treatment group? So thinking about the p-value a little bit more, let's go back to the normal curve that we've talked about earlier. Let's look at this normal curve. If the null hypothesis is really true in the real world, meaning that there's no difference between treatment and control, that the flu vaccine did nothing, then the most likely result that we would see is no difference, right around here. So if we're doing a bunch of samples, we're likely going to get some sort of result where the treatment group gets, say, 20% of people having the flu in that year, and the control group has 20% of people having the flu. So just by chance, we could get a sample where more people in the treatment group have a better immune system and are therefore less likely to get the flu. Also, if the null hypothesis is true, vice versa, right? That you could have more people in the control group that do better. These are all equally likely here and here. The p-value, let's say, is down here where we get the 2% difference. And this is the likelihood that we would see that 2% difference if it is just due to chance. If you are in a world where the null hypothesis is true, right? And let's think a little bit about these tails, that if you saw a difference of, say, 15% between treatment and control, that's hypothetically possible in the data, but extremely unlikely, which is why it's asymptotic out here, right? Where it's approaching zero. It's approaching a 0% possibility that you see that data just due to chance. So the p-value, you don't have to calculate it. It's calculated for you by your statistical software. So don't worry, there's no equation that you need to know for this. And it ranges between 0 and 1. Right? So 0 means that there is 0% chance that you find that relationship in the data due to chance. 1 means 100% chance. In practice, we're never going to actually see 0 or 1 because it's asymptotic, as I mentioned. It's never going to be, 0 chance. There's always a probability that it's going to happen. But those are the ranges that we see. And one thing to think about, if the null hypothesis is indeed not true, right? So that we do have an effect of this flu vaccine, then when you increase your n, you're likely to get a smaller p-value, that you're likely to become more and more certain that the result that you see is not simply due to chance. You're reducing the sampling error. Next concept that we're building up here is the significance level. And the significance level is the probability that we accept of a type 1 error. In other words, incorrectly rejecting the null hypothesis when that null hypothesis is actually true. So this is something, we're thinking that there is, at some level, an acceptable probability of alpha when you are incorrectly rejecting the null hypothesis, right? So imagine that there is, say, that 15% difference between treatment and control. I said that that was a level that, is probably really unlikely. And if we see a 15% difference, we're probably going to say, okay, there's always a possibility that null hypothesis is true, that there is no relationship between getting a flu vaccine and getting a flu, but I don't think so. So this is something that is set by the researcher. The researcher decides what is that level that you're going to be reasonably confident that your results have some sort of level of significance, that they are meaningful enough, right? And so this is somewhat arbitrary, what level you set it at. In practice, an alpha, a significance level of 0.05 is pretty typical in political science. So again, thinking about what this means, that means that we say it's acceptable that there's a 5% probability of incorrectly rejecting that null hypothesis. Alpha of 0.01 or 0.1 are also common, 0.1 a little bit less common, but 0.05 is a good rule of thumb to think about. And while it is arbitrary, anything over 0.1 isn't really very credible. So the final piece, bringing this all together, is statistical significance. And statistical significance is really just combining p-value and alpha, right? So statistical significance is when your p-value, what you actually observe in the data, is less than your significance level, less than that accepted level of probability that you said that you'd be willing to accept, right? So if you get a p-value of 0.03, and you accept it, you said you were going to accept at 0.05, well, 0.03, 3% chance that it's just due to chance, is less than a 5% chance. So you say, well, that's within the range that I'm willing to accept it. So here, this is where you say you have statistical significance. This is, say, 0.05, and here we got something that's 0.03. And so we say, okay, we're fairly confident that this is not simply due to chance.